This next video focuses on calculating slope. Slope is defined as the change, the relative change, the ratio between the rise between 2 points to the run between 2 points, right? So it can be thought of as a ratio of the change in y values compared to the change in x values between the same reference points. This is sometimes short formed delta y over delta x. Okay, the delta symbol is the Greek letter delta. It's shown by a triangle, and you've probably seen this in chemistry when talking about change in temperature as well. Okay, when we calculate slope, we find out how much change there is in a y variable relative to a change in by 1 in x. Okay, if we look at our first example, we're calculating the slope between 2 points that are telling us the relative concentration of toxin in blood over time. So at time 1, there's a concentration of 2 milligrams per deciliter, and at time 3, there's a concentration of 6 milligrams per deciliter. If we were to graph these, this tells us that the graph goes through a point 1, 2, 3, 6. Okay. And we want to figure out the slope of the linear graph containing those 2 points. Okay. So slope, as we said, is equal to the relative change in the y values compared to the change in the x values. So given 2 points, we can look at the change in the y values, the difference between y2 and y1, and the change in the x values, the difference between x2 and x1. Okay. Up above, we'll consider the first data set, point 1. We'll consider the second data information, point 2. So my y2 is going to be the y value from point 2. My y1 is the y value from the point 1. So my numerator, I'm going to have 6 minus 2. And then in my denominator, I'm going to take x2 minus x1 to find out how much my x changes by. 3 minus 1. So looking at those proportional changes, my y values had a change in 4. My x values had a change in 2. So overall, my slope is calculated as 4 over 2, or 2. Okay. The units for this are given by the units that my y is measured in. My y is measured in milligrams per deciliter, and this would be per whatever unit my x value is measured in. My x value is being measured in minutes. So therefore, the slope is 2 milligrams per deciliter per minute. That tells us that the amount of toxin is increasing by 2 milligrams per deciliter per minute. If we were to graph this, we would graph time on the horizontal or x-axis, labeling it with the unit minutes. The concentration of toxin would be labeled on the y-axis or vertical axis. It has units of milligrams per deciliter. The equation C equals 2T is given, and so the slope is 2. It's what we get also when we look at the relative change in y relative to x for any 2 points on our graph. Okay? As far as what it means, whether slope has positive values, if slope has a positive values, then the graph is increasing as we move to the right. We read graphs the same way that we read text. We read them from left to right, and so we can see with a positive slope, the graph is increasing. And if it has a negative slope, then the graph is decreasing. If we look back at some of the other graphing practice questions we went over in the previous examples, you'll notice where the slope was positive, our graph is increasing. Here we have a slope of positive 5. Our graph is increasing by 5 in the y value for every increase of 1 in the x value. Okay, and then when the graph is negative, or when the slope is negative, our graph is decreasing, and we see a relative change of -10 for every change in x. When our graph has a slope that's fractional, such as in example 3, when the slope is 1/2, what we see is an increase of 1 in the y value for an increase of 2 in the x value. Okay, because the slope is positive, the graph is increasing as we move from left to right. Okay. Let's look at another example. An IV drip is ordered for a patient. At the start, the IV bag contains 1,000 milliliters of fluid. 2 hours later, the bag contains 750 milliliters of fluid. We want to find the rate at which the IV bag is draining. Okay, so the rate of change, the rate it's draining, the rate of change is a measurement of slope, or another way of saying we need to calculate the slope. Okay, in this question, it might not be obvious what our 2 points are to begin with, but let's look. So we know that at the start, the IV bag contains 1,000 milliliters. Okay, to organize the information that's given to us, we might want to think about what our variables are and what our points are. So we know that we're looking at change over time. So our independent variable is time. It's being measured in hours. And then our dependent variable is the volume of IV fluid, and that's in milliliters. So initially, when t is equal to 0, the volume is 1,000 milliliters. Right? Later on, 2 hours later, the volume is 750 milliliters. Okay, so by reading that information, we can extract 2 data points, and we can use those to calculate our slope. Our slope, in this case, is going to look at the change in volume relative over time, because, again, our volume is standing in for the y variable, time is standing in for the x variable. Okay, so we look at the change in volume, V2 minus V1, relative to the change in time, T2 minus T1. So our volume changed by -250 in 2 hours, so our slope is -125, and the units would be milliliters per hour. That's telling us that the volume is decreasing by 125 milliliters per hour. Okay, we can relate this back to what we know about equations of lines. Equations of lines are always in the form y equals mx plus b, where m is the slope. So if I've calculated the slope, I know my m value should be 125. So my formula is going to look something like y is equal to negative 125x plus b. The b is supposed to be our y-intercept. We're going to talk about more of that a little bit. But another way to think about that in terms of graphs, those are our initial values, right? If we start reading from the y-axis and moving over. So in this scenario, because we know the initial value is 1,000, then we can make the equation y is equal to negative 125x plus 1,000. Okay? Using this, we could figure out how many milliliters will be in the bag after 5 hours. We would sub in x is equal to 5, right? And if you wanted to, you could even change the variables around. Instead of calling them x and y, we could use v and t. If you do that calculation, it works out to 375. And again, remember, v is always measured in milliliters here, so our answer would be 375 milliliters are left after 5 hours.